This is Mark Anderson from Kellogg Community College for Math 121 Intermediate Algebra. We are looking at Chapter 2, Section 1, Graphs. We're going to, let's see here, get my pen ready. We have a negative 10 to 10 on the two-dimensional coordinate plane. This is going to be your x-axis, the horizontal axis, and this is your y-axis. And the origin is located in the middle at 0, 0, right there. The axes are labeled horizontal and vertical right there, and the coordinates are going to be x, y. And the quadrants, this is the first quadrant. This is the second quadrant. I'm going to use Roman numerals here. This is the third quadrant, and this is the fourth quadrant. Now, what's nice about these quadrants is that you can tell a lot about the x and y values from where they are. Like, for example, the first quadrant, all the x and y values are positive. So we can put down like positive, comma, positive here for the first quadrant. The second quadrant, all the x values are negative and the y values are positive. The third quadrant, all the x and y values are both negative, so those are two negative signs there inside the coordinates there. And this would be the x is positive and the y is negative. Alright, now we are going to plot some points on this graph here, so let me clear this off and get to my pen again. So remembering that our coordinates are x, y, and these are x and y values, we would count from the origin to where 5 is on the x and 4 is on the y, and we'd put a dot there. And that right there is the first dot, and we can label it A. The next dot is 3 on the x and negative 4 on the y, so we go 3 and negative 1, 2, 3, 4. So like the game Battleship, instead of letters and numbers, we just use numbers for that. This is the y-intercept, 0, 5. So we're going to go up 5 on the 1, 2, 3, 4, 5 on the y-axis there. And we'll call this letter C. Letter D is an x-intercept, which is going to be negative 2 on the x and 0 on the y. So there's letter D. E is going to be negative 2 on the x, negative 7 on the y. And, whoops, that doesn't look like an E. There we go. That's not a good E. And letter F is going to be negative 3 on the X and 8 on the Y. So negative 3 and 8. All right, so there are our points right there. And that's the first part of our homework. And then the second part is to check to see if these are solutions inside of these functions. So if I plug 3 in for my X, and 2 in for my y, does this equal to 5? So using my substitution skills here, I'm going to plug in the numbers and use parentheses to show where those numbers were substituted. All right, which makes sense a little bit when you deal with negatives. And using order of operations, I'm going to see if 2 times 3 minus 2 is equal to 5. So this is 6 minus 2. Is that equal to 5? 4 minus 5. 4 is not equal to 5. So this is not a solution set. So the answer to this one is nope, no solution. That point does not lie in this function. And let's try this one here. So 1, 4. So the 4 goes in for the y, and the 1 goes in for the x. Let me put parentheses around there just to show where they went. And so this is 4 is equal to 5 minus 1. 4 is equal to 4, and therefore, yes, it is a point that lies within that line. And just as a side note here, this is the standard form of drawing a function, and this is the slope-intercept form of drawing the function. And we'll be spending more time on slope-intercept with section 2.2. All right, so then we're going to go here. We're going to plug in the x, but in this case, you'll see that instead of x and y, there's r and s. So you just have to follow alphabetical order. This would be the letter R, and this is my cursive letter S to show you that this is the R and the S. So this would be 2 times 4 minus, in parentheses, negative 3 is equal to 11. Now what's important about this, and the reason why I use parentheses, is I wanted you to see that a negative and a subtraction sign, it won't look so weird with the parentheses around there, but operationally this is going to be 8 minus negative 3, which you can swipe, or you can just add, because subtracting a negative is the same as adding. So that puts 8 plus 3 is equal to 11, and yes, this works. And now we deal with a cubic. So this function is a cubic function. It is not straight or linear, but we can just plug the numbers, do our little substitution. 2 in for the y, 3 in for the x, and that 3 is cubed, minus 5. So 2 is equal to, 3 cubed is not 9, it's 3 times 3 times 3, so it'd be 27 minus 5, and well, there's no way 27 minus 5 is equal to 2, so it is not equal to, no, it is not a solution. Alright, so let's scroll on down to the bottom half of this. I'm going to do some more graphing here, and in this case we're going to graph using the slope-intercept form. The slope-intercept form is going to be y equals mx plus b. And one of the ways that the book does this is that it wants you to build a table. And how you would build the table is you could take a number, like let's say plug 0 in for x, and we're going to plug all these in on the graph over here, but you plug 0 in for x, and then you go, what is my y value when 0 is in for x? And you notice that y would be equal to negative 3. And then you'd plug 1 in for x, and 1 minus 3 is negative 2. And then you'd look at, the graph when I plug 1 in for my x, it'd be negative 2 on my y, and you'd build a table out of this. And then you would plug in 2 in for x, 2 minus 3, and that would give you an answer of 1, or negative 1. So that would be 2, negative 1. And you would build points based on how many points that they asked you, and that would develop a line. Now I'm going to show you at the conclusion of me drawing these 4 lines, I'm going to show you how to do these on a calculator, and it'll take a little bit less time. And remember, the book wants you to kind of do these, plot them out, but again, if you have the TI-83 calculator, I'll show you how to do this. You're going to plug in 0 for your x and figure out what your y is. So y equals 0 plus 1, and that's going to be 1. So there's your start value for line number 7. I should put that as line number 6 here. So line number 7 is there. Then you can plug in a 1, and if I go 1 on my x, I get negative 3 plus 1, which is negative 2, which puts me right here at 1, negative 2. Then I plug in a 2 in for this, for my x, and I get negative 6. Negative 6 plus 1 is negative 5, so there's my next dot right there. And you'll notice that all these dots should be lined up, and the book will tell you how many dots you have to use, but if I'm running the example, I'm going to use 3, because if these 3 dots are not in a row, then I notice I made a mistake on 1. Now the absolute value, this is kind of an interesting one, and this is where I do want to show a little bit of work here. I'll show you that if you have, if you plug for my x and y, I'm going to pick some values here. I'm going to plug in maybe negative 2 for my x. If I plug in negative 2 for my x, that will make a positive 2. Positive 2 minus 2 is 0. So my point here is right there for my first. I'm going to then choose 0. I'm going to plug 0 in for my x. The absolute value of 0 is 0. 0 minus 2, so that's negative 2. And so my dot's right there. And then I'm going to go, let's see here, I've got, I'm going to plug in 2 for my x. Absolute value of 2 is 2, minus 2 is 0 again. So what I have here is I have this V shape for my line, which is line number 8. And you'll see that that absolute value creates V shapes. And I'll again show you how to do this on the calculator. Now the last one, kind of a really interesting one, is this graph with the square in it. And this parabola will make kind of a nice smile. And again, I'm going to write this down a little bit just to show you a couple values. I'm going to pick, just so I can get away from things a little bit, I'm going to pick negative 3 for my x, and I just picked that randomly. Negative 3 quantity squared is 9. 9 plus 1 is 10. So negative 3 would be 10, so that's way up here. I'm going to pick 0 there. 0 squared is 0 plus 1 is just 1. And we have that right there used up. And then we are going to plug in a positive 3. Positive 3 squared is going to be 9. And that gives me a 10. But what's really interesting about this is that this line, even though I only did 3 points, this line is not going to look like a letter V like number 8 did. This is going to look like a smile. And that smile can be realized if you do more points along the graph. Like for example, if I plugged 1 in for x, that my points would be 2 here. So 1 would be 2, and negative 1 would be 2 as well. And if I plugged in 2, that would be 4. 4 plus 1 is 5, and that would give me this point here and this point here. So it's more of a smile than that straight line. Now, as a little bonus for watching the video, I do want to show you the calculator stuff here. So let me have all this disappear. Boop. And let's drag up the calculator. I'm going to do a little edit here. Bring the calculator over. Okay. Now, if your calculator has been reset, this is the best thing, but a couple things to check. First, make sure your window is set up like this. Negative 10, 10, 1, negative 10, 10, 1, 1. Now, if it's not set up like this, you can just hit zoom 6, and that will get this to a blank graph. If you encounter problems, click the y equals and see if there is stuff in here, but this is where we need to go. And here's where we can type in our equations, since all of these are given with the y by themselves on the left side. Now, to type in x minus 3, underneath the mode key, you'll click the x t theta n key, and you will go x minus 3, and you'll hit graph. Now, on your homework, I can't have you sloppily make a graph, so you'll need to get those points. So by going second graph, you can get those points from the table, and the book may require you to do 5 to 10 points, so here's where you can get them. We're going to overtype that equation and type in negative 3x plus 1. Now when you type in the negative, make sure you do it by the enter key, negative 3x plus 1, and then hit graph. And there it is. Here's some other tricks. If you don't want to overtype your calculator, you can write it down below, and I'll start to do that to compare the next two. Now this is the absolute value of x minus 2, so you'll need to hit the math key, which is over here by the alpha key. Click to the right, and where it says abs, that's absolute value. Click that. So the absolute value of x, and then close that parenthesis off, like that's in parentheses, and then go minus 2. And you'll see it gets that V shape that I talked about. Now, underneath the y1, I'm going to type in x squared, and I can use caret 2, or I can use the little square key above the log key, and I'll put plus 1, and I can then compare both lines at the same time. And you see it gives me that smile. Now, what I can do is also turn them on and off by clicking the equal sign, and that will turn off one of the graphs or turn both of them on and off. So if you wanted to load up all your functions and then analyze them one at a time, you can do it this way. Well, this concludes the video. If you have questions, please let me know.